Hello students, I am Smita Parte and in this video I am going to discuss the risk and CISC, and this comes under the subject Computer Organization and Architecture. Here we are getting idea of risk and CISC by comparing each other on the different factors. So first point of difference we can say that what is the full form of risk and CISC. So this is the risk, and risk here reduced instruction set computers. What is the full form of risk? Reduced instruction set computers. And CISC it is the complex instruction set computers. Complex instruction set computers is the full form of CISC kind of architecture. And since reduced instruction set, so it is having the simple instructions, and since these instructions are simple, so need very few clock cycles for the execution. And after analysis we are having the figure that it needs 1.5 CPI. CPI stands for clock cycles per instructions for the execution of single instruction. But in case of CISC, since it is consisting of complex instructions, and so it needs multiple clock cycles for the execution. And what is the CPI for, on an average CPI for CISC architecture? It is the ranging from 2 CPI to 15 CPI, means 2 clock cycles to 15 clock cycles it needs for its execution. Okay. Then the performance issue. The performance is mainly concerning with the software. In case of RISC, the if software is good, then performance of RISC architecture is good. And in case of CISC, if hardware is good, then performance of CISC architecture is good. Okay, so this is the performance related issue. And in case of CISC, RISC architecture is having no memory units. So since not having memory, it uses separate hardware to implement the instructions. So it needs separate hardware, or we can say that it depends on the external hardware for its implementation. But in case of complex CISC architecture, it has its own memory unit to store all the complex instruction and to execute all the complex instructions. Okay, so this is about the dependency on external things of CISC and RISC architecture. Fifth point of difference is that in case of RISC, it is hardwired unit of programming. Means it is more programming is concerning on basically for hardwire. And in class already we have discussed what is the hardwire. And but in case of CISC, we need to implement the micro programs for the for getting work done by the hardwire of CISC architecture. So this is the programming point of view of RISC and CISC. But in case of RISC, it is, since simple it contains the simple instructions and reduced instructions, so having the few instructions in the instruction set, and those few instructions are very primitive in nature. But in case of CISC, it is having variety of different instructions, and they are enough good capable of performing the complex instructions, since not primitive instructions. So for real world kind of operations or real world kind of complex things, tasks which we can perform by getting the help of CISC kind of uh, architectures. Okay, now the in case of RISC is having less number of addressing modes for addressing the whatever instructions it is carrying. Since it is having dependency on the external hardware, so very few addressing modes are there with the RISC architecture. But CISC is having its own memory unit, so it can use the different addressing modes for the getting the for collecting the data from the memory. Okay, now in case of complex in case of RISC, complex addressing modes are synthesized using the software. So all the addressing modes they are they are using the software to get the data from the memory. Okay, in case of sys, it is already supporting the complex addressing modes. Okay, now the next point of difference is multiple register sets are present with the sys, but in case of RISC only single register set is there. And in case of RISC processors are highly pipelined, and already we have discussed about the pipelining, instruction pipelining, addressing pipelining. So pipelining is directly related to performance, how we are making different pipelining to get the parallelism in for parallelism in our execution. But in case of sys it is hardly pipelined. So this is the another point of difference. And in case of sys the complexity of risk lies with the compiler that executes the program. So, and in case of risk, it is complexity lies in the what microprogram we are making for the task to be done in case of CISC architecture. So this is the another point of difference. And now in case of risk, execution time is very less, but in case of CISC, it is very high execution time. And